All right, everybody. I want to first thank everyone for joining us at this workshop, Spinnaker Source to Production with Rollout Strategies. My name is Bob Boule. I'm the head of solution engineering here at OpsMx, and I'm joined by Nirmalaya and Gopi. We'll do some formal introductions, before we dive into the workshop at large. But again, I want to thank everyone for joining. The Band-Aid I want to rip off right now is in the event that those of you that don't know what OpsMx does, we'll go ahead and just throw that in there real quick, and then we can get on with the workshop proper. Our mission is to deliver software without human intervention. We are a company that obviously provides not only support but also a stack on top of Spinnaker, a layer of intelligence, if you will, that helps as you go down the path of looking to create decision gates, to create continuous verification gates, to ultimately go ahead and actually deliver software while collecting data from other tools in your tool chain, and ultimately making that data actionable as part of your Spinnaker pipeline process. And so we're really happy to be here today, obviously, and we wanted to just tell you a quick little background on sort of what it is that we do for those of you that might not be familiar with us. Today's agenda, I think we want to walk through leveraging Spinnaker in a source to production scenario, right? So you're going to see pipelines that ultimately are triggered from a source code repository, and ultimately being able to leverage various types of deployment strategies, whether that be a canary or a red-black type of deployment, gating deployments and automating rollbacks based on tests. We've got a number of pipelines that we're looking forward to walking you through, and ultimately showing you sort of what we've picked up in our experience as we work with customers to ultimately go ahead and sort of generate the types of complex deployment strategies that they're looking for in connection with their Spinnaker deployments. And so it's really something that this was an easy thing to sign up for because it's something that we're very, very passionate about. We've got some bonus material. We'll sort of deliver what we had planned, and then some bonus material depending on sort of how the time goes with, a canary deployment to App Engine, and ultimately, sort of showing you that sort of source to prod piece. And then ultimately, I've got a pipeline that I know that I've used with customers around AWS App Mesh, and we've got a review of those moving parts should we have time. If we don't get to those, guys, I would encourage everybody to visit us at our booth. I'll be there staffing the booth later in the conference, and certainly be willing to sort of fill in any gaps that we don't sort of get to today as we work through the workshop. So, who are we? I mentioned earlier, my name's Bob Boule. I am the head of solution engineering here with OpsMx. I've got previous experience, previous time with companies like TimescaleDB, a time series database, along with those of you that may know Black Duck software. I spent quite a bit of time with Black Duck and subsequently Synopsys as they acquired us. Let me bounce it over to Nirmalaya. Maybe Nirmalaya, you could give a quick intro.
Sure. Yeah, I have also been working in some big name companies like Oracle, Cisco, and some startups like Mapr, acquired by HPE, and Dremio. Have been sort of in this cloud space since early 2010s, and so very excited and see all the change that's happening in the DevOps space.
Excellent. And Gopi?
I'm Gopi Rebela. I'm the CTO of OpsMx. We've been providing CD solutions for a few years now, primarily based on Spinnaker. And before that, we worked with some large companies and startups and did some major transformations from on-prem software to cloud with microservices. And we are very passionate about delivering software without human intervention, although that's the vision. We are moving towards that very quickly.
Excellent. Excellent. All right, guys, now that you sort of know who we are, let's go ahead and jump in. And just so you know, I'm going to start with the first pipeline, and then I'll be walking us through this in sort of painstaking detail, running this pipeline, introducing some errors so that you can sort of see when things need to be rolled back, sort of how it works. And then I'll be transitioning it over to Nirmalaya, who's also prepared a pipeline that's based on sort of AWS, I believe, and using some of the build and bake stages within Spinnaker, and he'll walk us through that. So let me go ahead and just jump right into this. So the pipeline that I'm using here, guys, to sort of get us started, is one that I use quite often in our demos, only because it makes it very simple to sort of understand the range of Spinnaker and sort of how Spinnaker can work, and especially in this case here, I'm deploying to a Kubernetes cluster. And so we start off, with sort of the triggering event, and for us, more and more we've been talking to customers who are really trying to make sure that they're embracing sort of that GitOps model, where they want Git to be the single source of truth. They want Git to sort of be the center of the universe, and they want it to be able to go ahead and trigger, the various pipelines that are required to ultimately go ahead and actually deliver the software to production. Now, obviously, Spinnaker plays a critical role in that, in terms of being that delivery vehicle, being that orchestrator, and ultimately allowing you to go ahead and actually leverage all the tools around Spinnaker to sort of orchestrate that. But again, obviously, it starts with that code change, right? It starts with sort of what someone does or what modification that they make. They go ahead and actually submit that pull request. It's approved, it's committed, and then the process can start. And so as you're seeing here, my pipeline starts off with basically just a monitoring a simple Git repository. Now, those of you that are unfamiliar with Spinnaker in terms of how that works, what I've done here is I've simply set up a webhook where I'm actually being able to go ahead and actually, go ahead and log in there. It's going to go ahead and actually monitor, and ultimately Spinnaker is going to receive a push from GitHub based on this webhook. And then obviously I'm monitoring and asking it to send me everything. Now in this case here, I'm monitoring the repo. I'm actually looking at the master branch, and so obviously, as developers create their own working branches and then submit pull requests, those are approved. In some cases, there's tooling that will go ahead and actually trigger, sort of code review or, static code analysis or something along those lines. And then ultimately it gets approved and then promoted to master. I'm monitoring that here, the master branch of this particular repository. Now, the one question that I get quite a bit of is, hey, I want to monitor, I'm using a mono repo and I want to monitor just a certain artifact or a certain set of artifacts. Well, we certainly can do that as well, right? I mean, obviously, one of the things you can do here is define the file path that you want to monitor ultimately from this particular perspective, and ultimately narrow that field down in terms of what's ultimately going to trigger this pipeline. Now, the other thing that's interesting about this pipeline is it's really set up specifically to to show off the ability to have sort of separation of concerns. And so the actual Helm chart itself is being maintained by developers. Those are the folks that will actually make changes to sort of the chart and sort of the software and the way it's deployed. And then ultimately there's also the values.yaml file, or the configuration file for this particular Helm chart. That is something that ultimately belongs to the operations folks in a lot of cases, or the deployment folks or the DevOps folks who actually want to ultimately deploy the software and be able to make those types of changes. And so ultimately, we can go ahead and actually have those separations of concerns as we go through and do this. And so, obviously I'm looking at this Git repo. I've got my webhook set up here. And then ultimately, if I look at the code, I've got my values.yaml here. That's all set up. And as you can see, this is a Helm chart that is doing something very simple. It's simply deploying a Postgres database pod to a Kubernetes cluster, right? So very, very straightforward. And here you can see I've got the tag that I'm using is Postgres 11.3. If I were to sort of come over here, I'm connected to this database, and you can see here I've got Postgres 11.3 here, which has been deployed. And we'll come back to this as I go through and start to make changes to the way the pipeline runs. So that's the first piece of this, is ultimately the triggering event, and sort of how I want to trigger this and how I've wired this up to monitor my GitHub repo so that changes will ultimately go ahead and actually trigger a rollout. Now, the next thing that this pipeline does is it actually leverages Jenkins. So I'm going to recognize the fact that there's a change to the source code repo, and then ultimately go ahead and actually use a Jenkins job, in this case here, pretty straightforward job, to go ahead and ultimately build my Helm chart. In this case here, it's a real simple situation, and I always like to keep these things as simple as I can, just to make sure that nothing goes wrong when I'm actually demoing them. And so I'm doing this, and ultimately going ahead and actually depositing the resulting artifact in a cloud storage bucket, and we'll see that a little bit later. As you can see here, I'm using a Google Cloud Storage bucket to deploy the artifact to, or to go ahead and actually place the artifact in once it's done running. But I'm using my Spinnaker step here to go ahead and actually kick that job off and wait for it to finish. The next thing that I'm doing here is I'm going to go ahead and actually retrieve the artifact that I need here, right? So there's the Google bucket. That's where the artifact from execution is coming from. And then I'm ultimately going to use Helm 3 as a rendering engine to ultimately distill a manifest here. And again, I've used GitHub to ultimately trigger this pipeline so I can monitor and look for changes. And then I'm actually going to go ahead and actually retrieve the values.yaml file from there to ultimately go ahead and actually apply sort of the things that I want to ultimately go ahead and deploy this. And so one of the things is version of Postgres that ultimately gets deployed. And so in this stage here, we're going ahead and actually doing that and generating our fuzzy grasshopper artifact that will ultimately be used later in the process. The next part of this is to ultimately deploy this manifest. Now, I've got a really rudimentary setup here, again, because I use this, to demo to people and talk to people about it that don't have a lot of Spinnaker experience. However, it really does, sort of solve the problem in that I'm going ahead and actually targeting a Kubernetes cluster. I've got my artifact here. And so this is really the basics of me going ahead and pulling that artifact forward and ultimately being able to create that manifest and ultimately deploy it to my Kubernetes cluster. Now, the next part of this is, in this particular case here, I've chosen to go ahead and do a post-login check or a post-deployment login check. So what I want to do in this stage here is I want to make sure that I can address the database, right? So I have another Jenkins job that'll ultimately go ahead and actually, once this manifest is deployed and it's stable, it will go ahead and actually do that login check. Now, one of the things that I'm doing here is acting on that login check. So rather than insert, say a second or another sort of manual judgment step here to sort of have someone check this, I want to go ahead and actually have this test run. But, you'll note I'm ignoring the failure. So if it fails, I'm going to ignore that only because I want it to go on to the next stage. And what I'm doing here is I'm using a spell expression to ultimately, a conditional spell expression here to ultimately go ahead and actually process this rollout if I need it. So if you look down here at this spell expression, if the previous stage, the post-deploy login check, is in a failed _continue state, it will go ahead and actually undo this rollout. It will roll this back because that means I'm in a state where I'm unable to log into the database, and so I want to roll this back. And so I can automate that. Now, if the previous step just succeeds and is not in this state, it will not process this undo rollout, and it will simply let my existing deployment stand in production. So again, very, very rudimentary, very, very basic, but I think it's interesting to be able to sort of see these things in their sort of smallest form. To really sort of better understand sort of how it works and, sort of understand sort of what we're trying to show. Now, one of the things that I'll do next is I'll actually trigger this pipeline. So let's come over here and let's edit this file. And in this case here, I want to do an upgrade. I want to go to Postgres 11.7. So let's go ahead and actually commit that change to master. That'll go ahead and commit that change. And as expected, my pipeline has started to run. And so now it's going out and doing my Jenkins build and ultimately waiting for that response. It's gone ahead and got that Jenkins response, and it's built. It's gone ahead and actually distilled the manifest. And we'll wait now as it deploys that manifest. It's waiting for that manifest to stabilize, and we'll ultimately see that manifest stabilize. And obviously, those of you that aren't familiar, you can track a lot of that progress here as well. Spinnaker does a nice job of giving you sort of that visibility, and I can also see inside the pod, sort of what does the log console output look like, from this particular perspective. So it's gone ahead and actually completed that step, and that seems to be up and running. We'll just wait for that to sort of stabilize.
While you're waiting, Bob,
yes,
mind enlarging your screen a little bit?
Of course, yes. There we go. Is that a little better, Nirmalaya?
Yes, it is. It is, definitely.
Excellent. I'm just going to cluster here and make sure nothing's gone wrong. And there we go. And so it's gone ahead and done that deployment. It's completed the stabilization. And as you'll notice, the post-deployment login check succeeded, right? And so it went ahead and actually skipped my rollback step. And so that job succeeded, and so everything is working the way it's supposed to. Now, if this rollout went the way we were hoping it was going to go, I can come over here to my database, and let me go ahead and actually make sure that I'm connected. And what I should see is, and there we go, we went from 11.3 to 11.7. So I've now deployed the 11.7 version of Postgres by simply making those changes to that values.yaml. And again, I think it's very, very straightforward to ultimately be able to set something like this up. Now, this again is a extremely simple example of this, right? Extremely simple. However, I think it sort of makes the point. Now, what I want to do actually is I want to now introduce a failure here, so you can sort of see how this pipeline reacts when something fails. And so for that, I'm going to go in here and just change my post login check job, and I'm just going to give it the wrong password, so it simply won't be able to log in. But I mean, to Spinnaker, this is going to look like a failed job step, right? So any number of things could cause this to happen, right? And so, and now we're going to get to see, sort of what happens if I kick off the pipeline, and ultimately it is forced to do that rollback. So let's go back to GitHub for a moment. Let's go ahead and ultimately edit my file here, and let's see if I can't bump up the Postgres version to 11.9. Go ahead and commit those changes. Now again, we should see it, and there it is. It went ahead and actually triggered my pipeline, so that's going to start running. And like I said, what's going to happen here is it's going to get through all of these phases. It's ultimately going to be able to deploy the manifest, but the last phase here, this post-deployment login check, is what's ultimately going to fail, based on sort of what the changes I made to the Jenkins job. But of course, again, anything could cause that failure if for some reason there was a mistake in the port that was being used, because these things are all sort of settable through values.yaml. If that's indeed the case, that would ultimately trigger a failure. And so ultimately, what we'll wind up with is a situation where we're going to want to roll it back. And as we can see here, this build failed. So the attempt to go ahead and actually do that particular scenario in terms of testing this deployment was unsuccessful. And so now the job is in the midst of sort of rolling back that manifest that was rolled out. And so once this stage completes, what I'll be left with is I should be left with the exact same version that I had previous, which is 11.7. It should be taking that 11.9 rollout that was successful during this phase here, and ultimately now be rolling that back to something that that previous version. Now, again, guys, this is extremely linear and extremely basic, but I think it also sort of helps you see some of the capabilities and some of the things that you can do in terms of being able to sort of deploy, test post-deployment, and then ultimately automate, sort of rollback scenarios as they're required. And again, I think, this is one of those situations where, if you have a problem or you have a much more robust set of tests that you're running and you run into a problem, with this particular scenario, ultimately you can sort of automate that rollback if there's a hard and fast rule. Now let's go back to this here, and let's go ahead and actually just make sure that I'm not caching and I'm still connected to the database. And so ultimately, as you can see here, I just ran this query to select the version, and for some reason I'm at 11.3, so go figure, that's a live demo. What should be here is my 11.7. I'm not sure why that happened. I think there's a problem with my Helm chart. But ultimately, that rollback from that 11.9 should have rolled back to my 11.7, and I think I'll have to troubleshoot that Helm chart as to why that happened. But I think my problem is in that code. But as you can see there, guys, I think you can ultimately, again, if we were to look at this, I can ultimately do that deployment, identify a problem. Now, talking for a moment about sort of this post-login check, this post-login check can be a number of different things, right? So I can deploy this. I can run a continuous verification step against this using something like Kayenta or the OpsMx continuous verification if I need to. So there's a number of different ways I can go about ultimately understanding sort of whether or not something had succeeded or failed, and ultimately then process a rollback. And that ability to go ahead and identify a problem to the degree that you can automatically, and then ultimately process that rollback really demonstrates one of the more powerful elements of sort of Spinnaker. Because anytime we're sort of deploying in a very declarative way in terms of making sure that when we go and see a change in Git, we're ultimately rolling that change out. The ability to have that check or this sort of this safety net here, or this sort of fuse breaker to make sure that, hey, if there's a problem up front, and that problem could be something as simple like, hey, I deployed this thing and I can't log into the database, or something more complicated like, hey, I deployed this thing, I could log into the database, it started to accept traffic, but now I'm seeing some sort of anomaly, either in a log or metric scenario. And so again, all of these things are critical when it comes to doing this type of deployment, and ultimately being able to go through the process of understanding what's happening and then instrument that type of rollback, or ultimately instrument some sort of action that will allow you to sort of remediate where the problem might be. And again, making it really simple to be able to do that in terms of being able to automate or orchestrate those things. Now, obviously, the other piece of this is, sort of doing some of that testing prior to the rollout as well. So ultimately, if you were in, say, a red-black type of scenario where I might have, deployed my second version of this database, and then ultimately, or this, sort of maybe it's a stateless set where I've deployed a second version of this thing. and ultimately are running tests against that. And then ultimately, once those tests have passed and that's been promoted, I could then ultimately tear down the old deployment once I've got verification that that's been done. And so this is, again, one of those scenarios where I'm ultimately be able to do that here. We wanted to show it to you using Helm and ultimately being able to go through the process of going from sort of those changes to Git and then ultimately all the way through that deployment process to make it nice and simple and easy to be able to do that. And so ultimately, that's part of sort of what I wanted to make sure that we showed as part of this pipeline. We have a handful of other sort of similar pipelines that I want to show off, but let me stop there. And ultimately, what I want to do is I want to turn it over to Nirmalaya. He's got a different scenario that I think is it takes a different approach in terms of the type of deployment, and give him a chance to sort of show off his deployment there. And then when we come back, we'll start to talk about some of the sort of more traditional blue-green and sort of rolling updates, and I'll show you some pipeline examples there as well. Nirmalaya, do you want me to relinquish screen share capabilities to you?
Absolutely, Bob.
All right, hold on one sec here. And let me get to.
And while you're doing that, guys, if you have questions, anything, section where you can post your questions in there. Let me share my screen here and then talk through the next part of this workshop. I want to share a window. Share. Okay, hope you guys can see my screen here. So, taking off from where Bob left off, the whole thing where these things are going, or what Bob showed, is that really once a pipeline is set up, you don't need to do any deployment, right? You make the change to Git and it flows through the whole process and it's deployed, right? There's no extra deployment action being taken by anyone. So that's what tools like Spinnaker helps you achieve. And the other big advantage of tools like Spinnaker is its multi-cloud support, right? What Bob showed you was doing deployment to Kubernetes, right? Now, Spinnaker doesn't just stop with Kubernetes. It provides first-class support for providers like AWS, Google Cloud, Azure Cloud, right? But the concept remains the same thing, right? You build, you bake, you deploy, you validate, and if it looks good, you move on to production. If it looks bad, you roll it back, right? The same process goes on. And if you go look at Spinnaker, there are other folks are also coming in and adding support, Tencent Cloud or Huawei, Alibaba. So, there are other providers that is getting added. So that's the other great, nice thing about Spinnaker, that support for different clouds are also growing. So coming to the part that I'm going to demo, here is a little schematic of what my pipeline does, same as what Bob had earlier, is that, hey, my code is in Git, right? And, if there's a Git trigger, it would trigger off the build process within Spinnaker. Now, in this case, the build process would be in Jenkins, but it doesn't need to stop with Jenkins, right? It can, Spinnaker has support for other sorts of CI tools too, Google Code Build or Circle CI, things like that is supported. So in our build process, what the Jenkins job does is takes the Git repo, compiles it, builds, creates a Debian package, and then pushes that package to S3. Right? That's what it does. And here, let me walk through the schematic, and when we go to the pipeline, I'll walk you guys through that to how it's done in Spinnaker. So once you have built your package, you have your jar files or your Debian packages or RPM packages. You basically, in the world of VMs and AMIs and all that, you basically create your image, right? That's what's called the bake process. So in the bake process, it would generate your image. In this case, it would generate an AWS AMI. And in the process, it would pick up the image or the package that was built in the previous stage. Now, Spinnaker uses Packer to build it. So, any customizations, if you have Packer templates to build it, to build your images, you can absolutely include that to build your images. And then once you have your image built, you basically use Spinnaker to deploy it. What Bob did was he deployed it in Kubernetes. He deployed a manifest in Kubernetes that was baked out of Helm. In the case of AWS, it will deploy the same thing, or it will do the same thing, except it will take the AMI image and deploy it to AWS, right? And then it will monitor it. If it's successful, it will, you can say it, or you can tell it to proceed to deploy to production. Or if it looks bad, you can ask it to roll back, right? This process in our case is a manual judgment. A human comes in and takes a manual step and saying, looks good, bad, and proceed. But, like we have said earlier, our motto is, continuous deployment without manual human intervention. You really don't need a human being in there. Spinnaker itself has tools using which you can test your new deployment, do a canary deployment, test it out, and decide automatically if it should move to production or roll back. And even like Bob was mentioning, we in OpsMx also have extensions that can look at both logs and metrics and do a very good job of sort of deciding if your new release is at least as good as your previous one, and you can push it to production, right? So I'm going to show this to you. Now I'm going to walk through this application here. Before that, I'm going to create two pipelines, one that would deploy to a dev instance and one that would deploy to a production instance. And I have those pipelines in this Git repo available. I'm going to share this link in the chat. So in case you guys want to play around, if you have a Spinnaker setup and you want to play around along with it, you can absolutely go ahead and do it. So let me go in here. And so what are the setup needed to be able to deploy to AWS? Obviously, you need a Spinnaker installed here. I have 126.3 set up here, running here. Then you need to set up accounts in Spinnaker. I said I'd be deploying to AWS. I'd be using Jenkins to build, and then I'd be using GitHub, right? So let's go look at, if you go look at the Spinnaker documentation on Amazon EC2, it talks about how you can set up EC2 or an AWS provider in Spinnaker. They give three options. They provide some CloudFormation templates using which you can do it. You can follow the instructions here, or you can use AWS CLI to configure it. And they have the instructions in here, how to do it. And obviously, there is the long way of doing it. Every step is walking through the different steps in the AWS console. My take is that, if you can use this, you have an AWS CLI access and all that, this is the easiest of all. And then at the end of it, it also talks about what you need to do in Spinnaker to enable this, right? You enable the AWS provider in HAL, and then you add your AWS secret and key to Halyard so that Spinnaker knows how to talk to AWS, right? So that's one setup you have to do. And similarly, there are instructions how to add a Jenkins account, and as well as a GitHub account in there, right? So let's assume that I've already done those setups ahead of time in the system. So I have a AWS account set up, I have a Git account set up, I have a Jenkins account set up. So let me go ahead and create an application here. Let me call it AWS app, and AWS app, example, give it an email. And the cloud provider that I'm going to support in this is AWS, right? And again, nothing stops you from having different types of provider in the same cloud. Like if your application has both AWS and Kubernetes, you could absolutely do that. But I'm just going to stick to AWS here. So let me go ahead and create this application over here. So I have a brand new, fresh application. That's the overall sort of logical grouping in Spinnaker. By the way, I'm assuming that basic concepts of Spinnaker are known. So in case there's some questions around around Spinnaker, definitely feel free to ask questions. Now, like Bob mentioned, right? To do anything in Spinnaker, you need a pipeline. So I'm going to create a new pipeline here, and I'm going to call it as AWS Dev. Now, I can always go ahead and add stages here and go through the UI and define the pipeline. Now, Spinnaker supports a great GitOps model, right? Everything is managed as code. So even these pipelines are available as JSON objects, right? So there's the pipeline JSON. So what I'm going to do, instead of trying to build this all over here in the UI, like I showed you over here, I have these AWS Dev pipeline JSON over here, right? So I'm going to take this pipeline and paste it in there. So here is the raw version of that file. Control copy this, and I'm going to replace this JSON with mine. And let me update the pipeline. Okay, boom. There you have my pipeline in there. Now I'm going to back and walk you through the anatomy of this pipeline. Let me create the two pipelines and trigger it off. It would take about 10 minutes to run. And when it's running, I can come and walk you guys through the sort of the different constructs within each pipeline, okay? So let me save this and go ahead and create another pipeline, which is this was my dev deployment pipeline. And let me go ahead and create a production deployment pipeline. And I'm going to do the same thing. I'm going to edit this JSON, and I'm going to go ahead and replace this with my other pipeline. Boom, they have my other pipeline also in there, right? There's one change I need to, I have to save this. So let me go save this. So there's one change I have to actually make over here is I'm going to configure this. And, here I call another pipeline, my prod pipeline. Since when I created that prod pipeline was not there, I have to actually select that prod pipeline. So, this is a stage which calls another pipeline. It's in the same application. It shows me all the other pipelines that are available. I can just select it. There's this only other pipeline, AWS prod. I select it, and it's available, right? So just like that, I have two pipelines available for me to deploy. And they're available in Git. I can make changes. All the changes will be picked up. And you can actually have processes in place to have the sync between Spinnaker and Git and all that. So instead of making a change to Git and trigger this, I have the trigger disable. This is running on my local machine. I'm just going to manually trigger this pipeline, okay? When you have a pipeline, it can take in parameters and all that. I'm not going to ask it to rebake, but if you want any other input parameters, you can just provide that. Or those input parameters needs to come in as from the upstream. Actually, like I'll show it to you over here. If I try to start this manual execution of this, it wants an image that it should use to deploy, right? But in this case, I don't need anything. I'm just going to trigger this pipeline. That should trigger up this pipeline. It's starting to build this AWS Dev pipeline. If I look at it, I can always go to here. We would have a Jenkins link show up. I can go to Jenkins. Oh, let me do a spin, sign in. It will show me that console output. It's running there. Oh, it actually finished. It's going on over there. So let's walk. So while this is running, it will take some time. Let's walk through the anatomy of this AWS pipeline. So, like Bob was showing it to you, right? There are automatic triggers over there, right? So this one can be triggered by changes to your Git repo. This is in a repo called REST app. So if I go to actually OpsMx, no, not that. Let me go back. I don't want raw. So it's basically the source code is here. It's picking this up. And if I make any changes over here, it will trigger this pipeline, right? Which Bob was already shown you. He's making a change in Git, triggering the pipeline, so I skipped that part. You can have other additional triggers also, including, you can have a pipeline run at a certain time. You can have a cron job, actually, to trigger this pipeline at regular intervals. Every day, 11 o'clock, pick up the latest and deploy. You can have parameters, like we saw. And you can also have notifications, right? You can notify via different mechanisms, who all gets to see when it succeeded, failed, or when you want to be notified, when it's starting, complete, or has failed. So it has pretty rich notification options in there. And also you can have tags associated with it so that you can track your pipeline. So that goes for the configuration of pipelines. Coming to build. Yes.
Is it possible to zoom in a little bit more?
Sure, absolutely. Better?
Yeah.
Okay, good. Sorry, I should have done that earlier.
Yeah, you can probably widen the screen more if you want.
Sorry?
You can widen the screen.
Yeah. Okay. So basically the build is a Jenkins job, right? I have configured Jenkins, and I can choose what controllers. If I have multiple Jenkins, I can choose which Jenkins server to use, and it will show me all the jobs that's available in that Jenkins server, and I can pick the job to be done. And this is intelligent enough that it will come and show me all the job parameters that's needed. This job actually takes in an AWS bucket where to upload the Debian package that it builds. If you remember this diagram over here, it will build and push a package to S3, right? So that's what it does. And it will wait for the result. And if the build fails, it will fail the stage. And if you want, even if it fails, consider it as successful and move on. You could do that. And each stage also has all these options available. So, if you are new to Spinnaker, you can decide, so you can know what all these execution options do, is that it can help you hold the pipeline, or just ignore the failure. Or if there are multiple branches, parallel stuff going on, you can just halt this branch and let the other branches continue. So you can do all of those. Or you can even restrict deployment during a certain time frame or window. Or if it's running for too long, it should not take more than, say, 10 minutes. You can say that, hey, if the stage takes more than 10 minutes or 1 hour, fail it, so that you can take corrective actions. Or you can execute this on certain expressions. Bob showed you one where he executed the rollback based on the canary result. Or you can even fail the stage on expressions that you have. So a lot of nice options in there. And again, similar notification options are available, right? So in your pipeline, you can invoke Jenkins. If you have already invested in Jenkins, do I need to rewrite all my Jenkins jobs for Spinnaker? No, you can just use your Jenkins job as is in your deployment flow. Then baking of your images, right? This is what we talked about. We build it, now we have to bake it. And this is an important thing to deploy images or VMs in AWS, Azure, or Google. You need one of two things in your pipeline. You either need the bake stage, or what we'll see in the production pipeline is a find image, right? So that Spinnaker knows what image to deploy, right? So you need either a bake stage or a find image stage in your pipeline to be able to deploy VMs in the clouds. So this bake configuration, regular AWS stuff, in which region you want to bake it, what's the package you want to do, what's the base OS, what type of VM, pretty much standard AWS AMI image options out there, right? If you have extra Packer templates, you can provide them here instead of using the default template, which is the bakery in Spinnaker. That's the component that actually does the work of baking the image. You can provide the template file, Packer template file that you can use. You can provide additional attributes. Again, this is a simple showing how it works. You give the base AMI on top of which to build. If you have your custom, images in your organizations, you can use those to build it. And again, standard stuff is in here. So this is your bake stage, which actually builds the AMI. And then comes the deploy stage, right? And this is where you get into the deploy configuration. So let's go look at a deploy configuration, how it looks. And again, you could deploy in one deployment more than one server group, right? So let's look at this one. So you have to choose what AWS account to use, right? So in this case, I'm choosing my AWS account. It's an account that I've configured with access key secret, like I was showing you in there. Then I choose what region to deploy to, what VPC to deploy to. It will show you all the VPCs and subnets that are available, right? So it will pull all that information and show it to you over here. And these are names that you use to, you give to track your deployment. These are added as tags. Spinnaker uses these to manage and monitor the environments, right? So I'm giving this a stack name. I'm calling it SaaS cluster. This is just a name, right? And then, I can provide some sub information, right? This is my dev. When we go to the production stack, we'll see we call this SaaS cluster, and this one we called it as prod, right? And then you can control the strategies over here too, right? And you can have the requests sent to the new instances, and you can have red-black sort of strategy in there, right? Or you are doing a rolling push. though Spinnaker, it's still in it's experimental, not recommended. Or you can just not have any strategy deployed at all, or you can define some custom strategy, or Highlander. So there are different deployment strategies that are there that you can choose. We'll just choose red, black, right? And then, if the deployment fails, you can have it automatically roll back to the previous server group. And this is another thing that it maintains. For you to roll back something, you can actually tell it how many server groups to leave behind. If there's time, I can try to doing it. I know each deployment takes 10 minutes, but we could try and show that if I do another deployment, how it looks. The other thing that's important is that you need to have load balances. These you need to create ahead of time, actually, okay? It will, again, show you the load balances that are available. Now, we have only one over there. And you have to choose that, but you have to create this ahead of time. And I'll go to the load balancer tab and show it to you. Including also, you have to have firewalls, which in AWS parlance translates to security groups, right? So that's another thing that you need to actually create ahead of time so that you can associate it with your deployment. And I'll show it to you is that you can even edit some of these right from Spinnaker, so that someone who is using it doesn't need to have AWS access or need to understand the AWS concepts to be able to use these. And then the rest of these are standard AWS, machine configuration, what type of VM you're going to use, the capacity, how many instances, which availability zone, and then all the different other options that are there that you can enable, which you can typically do in AWS. So a lot of those options are available right here that you can do. So that's your dev deploy. And then there is a manual judgment. Let me go back before I come back and look at it and see if it's done or not, if it's waiting at this manual judgment stage or not, so that I can kick off the next stage here. And I'll come back again, walk through the rest of it. I do not want to make any changes, so let me revert it back. If I made any changes, let's go back. It is waiting on manual judgment. Wow, this did pretty quickly. Typically takes 5-6 minutes. So I'm saying everything looks good. I ran my test. I looked at my dev deploy, sanity test, manual test, automated test, whatever I did. I'm satisfied. It looks good. And then I'm going to promote it to production. So you can see it triggered off my production deploy pipeline, and it found the image that it's going to use. Actually, it was passed in from the stage onwards. So let's go look at that, what was happening in there. So manual judgment stage, as the name says, it's a manual intervention. You can have inputs the user can choose based on which you can take actions in the subsequent stages. One of those actions could be is that, hey, I want to push it to region 1, or I want to push it to region 2, and those can be options that the user can choose. And in subsequent stages, you can use that option the user has selected to take action, right? So what it does, if I say yes, is that I'm going to deploy to prod, which you saw earlier is another pipeline, right? So Spinnaker has this concept of you can trigger a pipeline from another pipeline, and there is no limit on the number of nestings you can have. I think I've seen 10, 15 level deep nesting in Spinnaker. So here it's calling another pipeline. If you remember, we came back in here and we had actually selected this pipeline when we created it. And there's this pipeline parameter. It's again taking a spell expression. What this is taking is that From the bake stage, take this parameter from the outputs, take this parameter and pass it along. And this is what you saw as being passed along as an AMI to the production deploy pipeline, right? So what had happened here is that it went in, did some testing, and then you decided to deploy to production, and it kicks off another pipeline, passes the image, right? So you can ensure the same image that was deployed in dev is being deployed in production. There is parity between dev and production. There's no different images being deployed. And then, if it doesn't look good, the release doesn't look good, you could roll back, obviously, right? Again, it's a stage in there, and you can choose what cluster to roll back over here, right? Now, let's go and look at the production deploy pipeline to look at what's different. Really, that parameter, I want to show it to you what's different. So this is running. Let me go into configure. This is that, like I mentioned earlier, right? You need to have either a bake stage or find image from tags. So in this case, it's basically finding the image from the parameter that got passed in, right? It had this parameter, which is this find image from bake stage. I think we should have had a better name for this parameter, because this was really passed in, but this is a parameter, and that same parameter is used to define the package that this pipeline should be aware of. Production deploy, really pretty much the same, except this name production here. If I go in there and look at it, pretty much everything is exactly the same, except this tag I'm giving. This is what Spinnaker uses to identify this deployment as being different from others, and will manage this instance. Let's go look at, again, I know I'm talking away. I have Gopi and Bob in there, so if you have questions, feel free to ask, and they'll be happy to answer those questions for you. Where was I going from here? Let's look at how it did. Nice and good. It's all deployed, done. Took about how much? About 10. Oh, this took 10, about 14 minutes it took to deploy, 14, 15 minutes to deploy this whole pipeline from beginning, where it did a build an AMI, deployed it, then went ahead and deployed it to production too. Now, Spinnaker is more than an orchestration engine. And that's what you can do, is basically look at these clusters from this cluster tab, right? These are the things that got deployed. I can look at it. I can act on it over here. And I can edit this. Now, before I show something over here, let me trigger off another run of the pipeline, and hopefully I can show something that I want to show you the power of Spinnaker. I'm going to trigger off another deployment. It's the same thing that's going to deploy, but I'm going to trigger it off. So while this is running, so let's look at the cluster here. So you can see that AWS App SaaS Cluster Dev Production. That's how Spinnaker tracks it. A V00 of this is deployed, and which maps to build 591. And the same deployment has gone into SaaS production, which also has V001, right? And there is a load balancer associated with it, right? It shows you all the load balancer available over there. And there is even an URL to that load balancer. What Spinnaker doesn't do very well is associate port and URL to it. But if I go to this guy, Obviously this would fail, but if I put in the right port and greeting, GRETING, there I have my application available, right? A nice cats and dogs demo. And I'm not going to do it here. In the other demos, what we do is we actually change the background in Git and have it go through the whole pipeline, and you see this show up as a blue background. So I can basically monitor the firewall and all that. I can also look at the different instances. Like, if I had deployed, if you remember, when we configured that server group, we said to have only one instance. If we had said that I want 10 instances of this running, we would have 10 little green boxes in here. And, I can look at each of them. When was it launched, where it's running, what load balancer it's behind it, and all that. And I can see even over here the console output of this thing, right? Which is a good thing, actually. I don't need to. There is some exception in bringing this one up, but I can, or there was some exception in running this AMI. But I can look at an instance that is running and look at its output right over here without having to go to Spinnaker and all that, or without having to go to AWS console and all that. Then I could actually terminate, reboot the instance, or even shrink the server group. I can terminate and shrink the server group too. Or if I actually look at the whole server group, I can take actions on the server group. I can resize the server group and say, hey, resize this to 2, right from here, without having to go through any other things. Hey, I have a production issue. I need to add vertically scale this and add one more instance. Increase this over here, and there you go. You have another instance up in there. So I can take actions to my server groups right over here, including cloning, destroy. So that's another big advantage of Spinnaker, where it's not only deployment, but you can also control what you deploy from here. And then you can have your load balancers. Same thing with your load balancers. You can even edit your load balancers and add additional protocols. Here, this one is routing 8080 to internal port 80, right? You can add additional health checks and all that things that you can add to the load balancer. That's sort of giving you the AWS pipeline, how it works, what you can do. I was waiting for this to go into deploy and show you how it works in there. Let me see if I can show you with another application, and then we can move on with the rest of the demo. If I go to AWS, this is another cluster I had done before. So as I do multiple deployments, what would happen is that it would deploy V001, V002, or V003, like that, right? And then it will disable this. You can see that this one is sort of bright, and this one is sort of grayed out. That means these are disabled, right? The clusters are still there, but it's not connected to the load balancer, right? You can see the up is 33% because these two are not connected to the load balancer, or the load balancer is not routing traffic to these two guys, only to this one. So as I deploy, this is what the red-black deployment would actually do for you. It will automatically do for you without you having to take actions to control these things. And you can control how many of these you keep them around or roll back and all that. And like if you want to do it here, I want to just go ahead and delete this server group. I can go in there and do a destroy and ask it to destroy it, and it will go ahead and actually destroy that server group for you from here. So you can do all those things like that. So there was some error undefined. Hopefully that's not related to this. Obviously, all sorts of things happen during demos. That was one of them. Let me try to find my AWS app. Okay. I think I'm running this locally, and I'm probably stressing my local environment up. You can see the amount of CPU. Yeah, something definitely, or it's probably coming up. It's being deployed, it's coming up. So at this point it's red, but it will turn green, and this one should take over. So that's about deploying to AWS. Same thing what Bob showed, but with flavors of AWS, cloud deployment, and same thing you can do in Google Cloud or Azure. This is what monoliths, we're talking about. If you have VMs, you're not on Kubernetes. Am I ruled out of Spinnaker? No, absolutely. Spinnaker supports such things, such deployment models for you. With that, I don't think I had anything else to cover here. Are there any questions that is better answered than in chat, Gopi?
So I know we got one, guys, on. By the way, Nirmalaya, thank you. This was great, and I think we did get one question, and maybe Gopi, you'd want to speak to it, or Nirmalaya, whichever one. Can you explain how to incorporate secrets as part of a Spinnaker pipeline?
Okay, let me take a stab at it and try to do that. So one way to incorporate secrets is, especially for Kubernetes, is that you can have secrets available in Kubernetes, right? It's a process. You can either deploy a manifest, or your Kubernetes cluster is, say, synced up with Vault, and your Kubernetes cluster has access to those secrets, and so you can use those secrets in there. Another is injection of secrets into a pipeline. One drawback of that is that those secrets are available in the pipeline execution context, though, right? It can come in, you can make them as variable and then use those variables as spell parameters. But the drawback of that is that those are available in a pipeline execution context. So that's one. Gopi, the other ways to handle it?
Yeah, so typically secrets, we do provide flexible mechanisms. So with Kubernetes, there are integrations that you can have with cloud native KMS, SMS, or Google Secrets. So we do support those. When you deploy your deployments, you can do the annotations to integrate with them. If you use something like HashiCorp Vault, those integrations are available, but not natively with Spinnaker, but you can have those easy extensions we provide as part of that OpsMx enterprise one. We also ship that HashiCorp Vault with it. There are multiple mechanisms of managing secrets that hide the secrets themselves in the pipeline. And at the deployment time, using annotations, injecting them, or having a sidecar mechanisms to inject them is a more acceptable way of doing it, and we support those mechanisms.
Great. Excellent. Excellent. There was another question, and we'll deal with another question, and then I've got a couple of other pipelines that I was going to walk through, guys, just to sort of give folks a flavor for, hey, what if I want to go beyond a simple manual judgment step, and I want to run some analysis. And so I'll spend some time talking about a little bit about that. But there was another question from the audience. Looking to automate spinning up Spinnaker in different cloud environments. And guys, when I hear something like that, Terraform is what comes to mind. But maybe you guys want to maybe speak to, sort of ways to go about automating spinning up Spinnaker in those environments.
Sure. Let me take a stab at it, and Gopi, if you have other things, you can add it. And in fact, in few customers, we have done Spinnaker, eating your own dog food. Spinnaker spinning up Spinnaker. So, so for some customers, what we have done is that we have Spinnaker pipelines that actually spin up Kubernetes clusters. Like you said, it does use Terraform, but uses Terraform to spin up Kubernetes clusters. And then we have Helm charts to deploy Spinnaker. And so then, just like Bob showed, using Helm charts to deploy, you can use the Helm chart to deploy Spinnaker, and definitely, like, there's a extra flavor of OpsMx, Enterprise Spinnaker with some extensions. We also have Helm charts for that. So those are things that definitely you can do to automate the setting up of Spinnaker in different cloud environments. There's also, I think there's a question about maybe setting up the accounts and all that. That's where the GitOps model is very popular. There are two things that are done there. One is Spinnaker itself has support for dynamic accounts, because you may have accounts coming in and being created. How do you do that? So you store them in some store like S3, Git, and all that. And Spinnaker would automatically pick them up. It does that very well for Kubernetes, and support for AWS, Azure, GCP are coming in for those things. And also for Spinnaker config, what we do in our setups is follow the GitOps model. Like, it's not just code. The Spinnaker configuration is also managed in Git. So that you really don't go to Halyard and make the changes, but you have Git in there and make the changes in Git, and then have that trigger a Spinnaker pipeline that would refresh Spinnaker itself. So that's another model that is used to basically not only bring up, but also keep your Spinnaker configuration in sync with Git. That provides one of things is that, auditability and making sure, someone's not messing around. You're not getting config drifts in your environment and all that, and everything is managed properly. So that's how you can actually automate setting up of Spinnaker, and or even managing the accounts. And definitely, like, there are more questions around this, drop by our booth. I think, Bob, you're going to flash our booth information at the end, right?
Of course, yes.
Yeah, so definitely, drop by our booth.
Awesome. And correct me if I'm wrong, Nirmalaya, but Nirmalaya and Gopi, but this is one of those things where it was a need to be able to do this, only because outside of that, you either had to centralize administration, and the administrator needed to go into Halyard and create these things, and then ultimately go through the process of restarting, versus being able to do this in Git, where you get the natural sort of approval phases, and you have sort of one single source of truth that can be done outside of having to log into the Kubernetes cluster that Spinnaker is deployed on. Is that a fair statement in terms of the goodness around that GitOps model and sort of where customers see value?
That's right. Yeah. So the infrastructure automation through Terraform kind of tools or CloudFormation for AWS, and then lifecycle management of Spinnaker, configuration management, upgrades, and all of those through GitOps model using Spinnaker itself is the model that we found to be most easy to maintain.
Excellent.
That's automation we do mostly.
Excellent. Okay, great. So guys, let me, if you don't mind, I was going to jump in and maybe walk the group through a couple of other pipelines, right? I've got a couple of blue-green examples here with some traffic shaping that we can look at, some canary analysis examples that we can look at. So when it comes to things like doing verification. So any objections to me jumping in and doing that?
Please go ahead.
No,
Okay,
go ahead.
excellent.
Go ahead, Bob.
Excellent. All right. So, we did want to walk you through a couple of other pipelines. Wow, that was a trip. The inverted screen share. There's a couple of other things that we sort of wanted to walk you through. And these were pipelines that, again, that we've set up, we've worked with customers on, we work with prospects on all the time in terms of being able to go ahead and do something like a canary build and ultimately go through the process of deploying that canary, ultimately, putting some load on it, but also giving you sort of the data that you need to sort of make decisions around whether or not to approve and roll that canary build forward or to roll it back, right? And there are a number of different ways to sort of go about doing that. But in this case here, again, we have, sort of a sample pipeline where, we're actually deploying the canary build or creating the canary build and then ultimately deploying it, that canary deploy. And then ultimately, we're going down the process of running a set of tests, right? So in this case here, again, a very, very simple scenario here where we're doing that canary alongside the baseline. We're ultimately going to go ahead and actually start to test or run some load tests on this application to ultimately get to a place where we can then perform that canary analysis. And that, in this case here, is using Kayenta within Spinnaker. And ultimately, what you end up with is, the ability to go ahead and start to evaluate the results of these specific builds. And sort of, in this case here, we're looking at, or as we set up Kayenta, we're choosing the metrics that we want to monitor and ultimately are able to go ahead and actually look at this deployment, this candidate deployment, if you will, versus our baseline or our previous or current production deployment under the same set of load. And ultimately, what we're doing here is producing that data-driven result set that ultimately you can use to decide whether or not something is to be promoted or is to be rolled back based on what you're seeing here. Kayenta does a nice job of incorporating various data sources right through Spinnaker and allows you to go ahead and actually map those baseline and canary metrics side by side. And again, ultimately allow you to go ahead and just that, you heard us mention, manual judgment steps, right, throughout this process. And I think it's worth noting, sort of what does one do during a manual judgment step? What should I be doing? And I think it's really about, looking at things like this that will help you make, again, that data-driven decision as to whether or not, we all can get a binary pass-fail, from our testing scripts. Did it process the load and did it do it in a certain period of time? But to go that next layer deeper and say, how did it behave while it was doing that? And what are the risks associated with this particular canary deployment? Now, if everything's in line, I can go back to that manual judgment step and simply go ahead and approve it. If things don't look the way they're supposed to, or if I see anomalies in the way that the underlying application behaved while I was testing it, again, I can go and ultimately roll that canary deploy back. And again, I think this is something that we see a lot of our customers starting to try and do this and look for ways that they can ultimately sort of manage the risk associated with these deployments. And, being able to add steps like this to your pipeline to generate this kind of data and make it available to you so that you're not, sort of relying on, simple pass-fail. And you're going that layer deeper to sort of make that decision. And then ultimately, as the whole thing moves forward, you're ultimately going to be able to, look at, again, whether or not you should, as you check those conditions or you insert a manual judgment step or approve and validate the canary, this is the data that you'll be looking at, and then ultimately make that decision as to whether or not you should promote that canary to production. And again, I think this is something that's in Spinnaker, is available to you, and again, a very powerful tool for sort of making those types of decisions. And again, I think we can incorporate this regardless of sort of the type of deployment that we're looking at, again, by simply wiring up Spinnaker to those metric sources and allowing it to gather that information and leveraging those setups. And ultimately, if you go through here and look at the configurations that are available, and defining sort of the metrics that you want to look at.
Bob, I
Yes.
just interrupted. Can you increase your screen size?
Oh, yes. Seems to be a theme with us, huh, Nirmalaya?
Yeah, you have a large monitor.
Yes. And so we can ultimately define those metrics that are important to us when we're looking at these things. And so, again, I think it's important to understand and have some data, or to be able to make a data-driven decision as to whether or not something should move forward. And using something like this is extremely useful in sort of making that decision. And again, I think this type of pipeline is fairly straightforward. We have customers that do something very similar in their blue-green deployments, where prior to tearing down the old deployment, they'll monitor the new deployment in production and run an analysis like this, and then ultimately make sure that they're in the clear. But if they had to roll back, they could do it very quickly, versus maybe a more traditional canary where you're testing it and running load against it, or you're exposing in some cases. And I think I've got a pipeline here that we can actually show where we're doing some of this work. We'll use this App Engine pipeline where I can ultimately expose a small portion of my traffic to sort of that canary, and ultimately be monitoring that data and ultimately making that decision. So there's a lot of different context in which we can do this, but the idea behind these things is, let's make sure we have some data on top of which we can base a decision to sort of either move forward or roll back. And Spinnaker has that goodness built right into it through Kayenta, making it extremely easy to sort of get access to that type of information, regardless of sort of the type of deployment that you're doing. If it's being fed traffic, you can ultimately wire up and monitor those metrics and make that data-driven decision. The other pipeline that I wanted to show off to you guys that I think is interesting, and it's something that we just have started to work with a particular prospect, and ultimately going down the path of using some traffic shaping technology. So a lot of our customers are now experimenting with Istio and other sort of traffic shaping technologies. In this case here, we had a prospect that was working with AppMesh, and so the ability to go ahead and actually sort of deploy the various services that you need to through Spinnaker and interact with AppMesh. Obviously, this requires a controller, an AppMesh controller, to be installed in your EKS cluster, but ultimately being able to start the process of controlling that traffic with an idea of creating, again, when we look at this, those virtual routes that would allow me to go ahead and actually add weighted traffic here. So in a blue-green scenario, I'm going to flip a switch and go from 0 to 100 or from 100 to 0. But in a canary scenario, again, I could change these routes to receive amounts of traffic that I want. I can expose a small amount of the traffic to that candidate build, and again, ultimately bring in an analysis tool like Kayenta to be able to ultimately go ahead and analyze that data, that metric data, while this is being pressure tested, while it's receiving some of that production traffic. And again, wire it up to this and ultimately make that decision, whether that decision is manual or automated. So this goes to sort of talking a little bit more about taking it a step further than sort of my simple example of, hey, can I log into the database, if not roll back, assuming that I can pass those functional tests. this is sort of that sort of performance test that I can ultimately start to measure and look at, sort of what's happening with the build as I start to apply pressure. And there are a lot of different sort of techniques around this. Again, depending on the situation and the safety net that you require, you want to make sure that, you're either exposing a small amount of this traffic, or if it's going to be a binary sort of 0 to 100, 100 to 0, that you actually take into consideration some of that metric analysis and that data, or that comparison to a previous build, prior to sort of making that decision to either tear down a previous or promote that canary. And so this is something that I think, in the spirit of this workshop, we wanted to make sure that we talked a little bit about in terms of Spinnaker's ability to ultimately interact with these various services, not just do sort of the out-of-the-box red-black that Spinnaker ships with, which is obviously, we have a lot of folks out there that are taking advantage of that. But if you want to explore other technologies for traffic shaping, or you want to use Ingress for traffic shaping, you certainly can do that here, and ultimately, again, make those decisions based on data, and not just sort of binary pass-fails, if that makes sense. Let me stop there. I don't know. Before I move on to the last pipeline that I wanted to show, Nirmalaya or Gopi, anything that you wanted to add, or am I missing anything from that perspective?
No, you're good.
Okay, excellent. Take a deep breath, because when I always ask people that are smarter than me if I got everything right, it's always good to hear that I did. So guys, the last pipeline that I wanted to go through, and then I think we'll do the best we can to sort of, I see in the background there some additional questions coming in, and let me first start by making this bigger. Another piece here, and I show this off just because, again, it's sort of another technique that shows the power of automation and the ability to go ahead and actually automate things like validations, right? And so here, this pipeline, there's a sort of rolling upgrade going on here, right? Where, we're deploying a green deployment, and then ultimately we're doing a 30% traffic split. And then ultimately, once we've done that 30% traffic split for a period of time, we're then going ahead and validating that traffic. And in here, again, we've represented this as a manual judgment step, but one of the things that you might do here is, again, kick off that continuous verification analysis, whether you're using Kayenta or something like the continuous verification within OpsMx Autopilot. Anything that would allow you to get more insight into sort of the health as you're actually starting to stress these deployments. And then, of course, assuming this passes, we then up the ante here to a 50% traffic split. And again, do another validation there, right? And again, I'm sort of slow rolling this out and ultimately going through the process of, at each step along the way, using the data that I can collect, from the metrics perspective, or in the case of the OpsMx stack, both logs and metrics, to ultimately understand what the health of this is. Now, again, this is particularly interesting, and we've talked to a lot of customers who are, again, utilizing that sort of source to prod sort of GitOps type of scenario, where they're sensing, or they've identified a change in Git. It's been approved. You have sort of tests passed from a sort of code quality perspective through the pull request process, and then ultimately rather than sort of pick an all or nothing type of scenario, they can run that code through a pipeline like this, where they can ultimately start the process of slowly adding that traffic to make sure that they're not running into any problems, and analyzing it every step of the way. And again, using the data-driven approach, right? So whether or not you're sort of using that Kayenta piece here to ultimately sort of look at these metrics and ultimately understand if there's anything out of whack here, from a time series perspective or a histogram, or if you use, again, something like our continuous verification piece, where we're going to produce a score that ultimately allows you to anchor a decision to, right? So at each step along the way here, you can ultimately go ahead and ultimately ask yourself, are there any anomalies? Is there anything I need to be concerned with before I start to deploy this to even more or expose this to even more traffic? And so, again, I think, guys, the key here is all of these strategies, obviously are enabled by the underlying technology using something like Spinnaker. I also wanted to comment on what Nirmalaya showed you at the end of his demo, which I think is particularly powerful, is, as well as things can go in a scenario where, you've gone ahead and deployed something, there's always sort of that 3 a.m. situation where you may need to take action. And I think that's really where Spinnaker excels in allowing you to interact with those clusters, to be able to scale those things. So if you have the same underlying software, but the problem is you need to scale that deployment, something that you can do right within Spinnaker, that sort of brings you back to sort of that single tool to be able to manage these things end to end and make sure that there aren't any issues, or if there are issues, your team has the right tools that they need in order to go ahead and deal with those issues. And again, it allows the pipeline to focus on deploying net new software, and then obviously going through this process that you're seeing here to ultimately validate that software, depending on how you want to do it, and then ultimately leading to the ability to go ahead and interact with that cluster, as you need to, and respond to the environment as things, if you need to again scale up, or if you're again looking to later in the evening scale back down. Again, you can do all those things right through this single tool, and ultimately be able to track all the things that are happening and all the ways that these deployments are being interacted with. So, guys, that was sort of what I had. Again, I guess I'll go back to Gopi and Nirmalaya to see if there are any things that you guys wanted to add, or things that you think maybe I may have missed. Happy to have you guys fill in those gaps there, if that makes sense.
No, I think you covered it very well. I like that one. Emotional outbursts.
Well, I like to be comprehensive when we ask people if they've got any questions, concerns, or if they just saw something that they thought was either crazy or insane. Please feel free to let us know. We love the feedback. And by the way, and I'll stop sharing so I can go into the questions piece here. We can maybe take a look at a couple of questions. If for some reason you want some additional information, or you just want to continue the discussion, let's say if you have a situation that you're dealing with right now that pertains to some of the things that you saw today, stop by the booth. I know I'm going to be doing some booth duty, and I'll be there for a period of time. Members of my team will be there staffing the booth and be more than willing to have you come in and ultimately ask any questions or any follow-ups that you have, or maybe even set up a time to talk about your particular situation. We'd be more than happy to sort of help you there from that perspective. With that said, let me stop my screen sharing so we don't have to look at the window vortex, and I guess, guys, open it up to sort of any questions. I think we were able to present all this a little faster than I had anticipated, and so I think, but we do want to make sure we leave some time for any questions that people might have, or again, have you guys feel free to sort of come by our booth and interact with us directly.
So I see a question in there. In enterprise with many teams, do you recommend having distributed Jenkins per team and auto-trigger pipelines after Jenkins, or via Git trigger from Jenkins from Spinnaker for CI builds?
That's one of the beauties of Spinnaker, is those choices, right?
Yeah, and I don't think there is any right or wrong answer there. It's what is comfortable for you. If you already have a process set up where Git check-in triggers Jenkins, you just stick with that, right? Don't change it. And then from Jenkins, trigger the deployment pipeline. If you're building something new and want to have Spinnaker as the center of your universe, sure, have Git trigger Spinnaker pipeline, which can trigger the Jenkins build and proceed. I don't think there is, basically both the opinions are strongly supported by Spinnaker. Spinnaker doesn't take a side in there.
Yeah, and I think I love that answer, because I think what it does is it basically tells folks that, you know, there's going to be a right answer on a per customer basis or on a per user basis, right? Each team will have you know, sort of a preference, and one of the nice things that I'd like to talk to people about Spinnaker is that ability to have that flexibility to sort of choose how those teams want to work. And I think we've seen it in our customer base in terms of you know, offering up CD as a service internally and allowing, you know, those individuals within the organization to sort of decide how they want their pipelines to run. So yeah, makes sense.
One consideration here is when you have multiple tools being part of the delivery, and if you want to go trace how an artifact or container got to your production, then you want to look at multiple tools, right? If you want to go trace and audit those. So that would be one of the considerations. And there are newer things that we also have provide an enterprise version, which allows you to collect all these events in one place, gives you the traceability. So that also adds to the flexibility in which how you can use Spinnaker to orchestrate your delivery. And even there, you have these options of the delivery, the container immutable server deploying to your dev environment, testing, and then a separate pipeline that's triggering off the deployments to your production. Usually, if you're using Argo kind of as tools where you have the Git process that's linked to each one of these deployment environments, you get into those situations. How do we correlate all these events? And so that's one of the considerations, and usually the enterprise tools, event correlation needs to happen there, which is one of the things that we can support you with.
Excellent. Excellent.
There's one more question I can see. Secret config maps can be used in case of Kubernetes, but how will we manage such secrets config files in AWS? Let me take a stab at that, and Gopi, if there's another option, call me out. So I think the way you manage that is that once you have an AMI, you just bring it up, right? This is the immutable infrastructure construct that Gopi was talking about. So where you handle secrets and config files in AWS or in other such VM instances is during your bake process, right? You have your images, and when you bake them, you basically provide them as parameters and, you know, make them part of your image and bring them up. Now, if there are other environment variables you can do it, that you can do, but, you know, if it's configuration or something, you basically make them part of your big process and, you know, build the image and then deploy the image as part of that same immutable infrastructure construct. Anything else, Gopi, that comes to mind related to managing secrets in AWS type scenarios?
In AWS type scenarios, yeah, using SMS, KMS structures and integrating with IAM is the simplest way to go. That can go as part of your image baking. You can set up the user data to go fetch the secrets and run your application.
Sure. There's another question. Does Spinnaker have the ability to run in an active-active architecture today? Answer is yes. Now the active-active, Spinnaker supports multiple instances running, right? So that active-active is in the same region. If you want an active-active cross-region, there's some work to be done because it does use databases and caching to maintain some state, and the latency of those are very important, right? So yes, you actually run a high availability version of Spinnaker. Again, and that defines what active-active means. So again, it's up to definition of the active-active that someone's looking for.
Well, that's great, because
But
I know that's a topic we've helped a lot of customers with, and so I know Gopi, I didn't mean to cut you off there. I just wanted to mention that this is something we've helped a lot of folks with, and so if you have additional questions about this, feel free to stop by our booth.
Right. No, I was going to say that when you run active-active across multiple regions, for example, then the persistence layer needs to be updated. Yeah, we can talk to you about your requirements there.
Excellent. Excellent. All right, guys. I don't see any other questions. Folks,
there's another question.
Okay.
So can we hard code server IPs while deploying onto AWS?
You actually use the load balancer IP. So each servers, you don't typically access each server individually. And your load balancer has an IP address. So typically you don't want to control those. Again, we have not done that, or at least I have not done that. So definitely would love to hear why, what your use case is about requiring each server to have a hard-coded IP address in there rather than let AWS manage the IP addresses, which should be internal, not public. And your public IP address, which doesn't change, should be the IP address of the load balancer.
Okay.
There's one that popped in right now. And
Yes. Yep.
Okay, you're going to read that now? Yeah.
No, go ahead. Go ahead.
Okay. Is it possible to run Spinnaker on AWS and Azure cross-cloud with single DB and operate on both? Being run on Azure, we can use MSI and avoid service principal and avoid service principal and AWS iron role. I think this comes to the point that Gopi mentioned. Latency of access to the DB is important. Again, we don't know. Trying to run cross-region databases, there are latency issues, and Spinnaker doesn't seem very happy. I don't see why those latency issues won't be there when you're running cross-cloud. I think you should really evaluate your scenario. It's best to leave it in one region. It's my view at this point.
There's one other question on the Canary. What is the best way for applications that don't get a lot of traffic or traffic is not constant to be able to use Canary? With metrics alone, when we are, it is kind of verifying the performance of your application. So if you don't have enough traffic that's statistically significant, then we cannot really compare the performance. The obvious one would do is use the thresholds. Another option that we add to it is that you also verify logs along with the metrics. So you run the Canary and you focus on the errors or functional aspects of the Canary and use statistical thresholds for performance metrics. So the combination of that would allow you to do a better Canary in an automated way. That is something that we provide as part of our service.
Excellent. Excellent. Let's see here. I'm just bouncing back and forth between the chat and the QA section.
Right. That one is.
Yeah, that one is a little weird. It would have been nice if it was in one place, right? So.
Yeah. No, it's just to make sure we haven't missed anything. And while we're waiting for maybe any sort of last minute questions to come in, guys, again, I know. If there's a specific interest or you'd like to go deeper on a specific topic, I know these workshops are hard to sort of air your specific scenario. I think the three of us are more than happy to sort of make ourselves available to have sort of those more private conversations where you want to maybe talk to us a little bit about your particular scenario. We'd be happy to do that. So don't be shy about reaching out or stopping by our booth, and ultimately making that ask, and we'd be happy to schedule something. Let's see here. Well, looks like we got something else. If we have to deploy multiple versions of a single pipeline, usually in case of we want to shift partial traffic, use case for canary-based deployment, do we need to rebake the Helm chart?
Oh, that was earlier. Okay.
Yep.
That's the other thing. In the chat, the latest is at the bottom. On the Q&A,
okay.
The latest is at the
there
top.
we go.
So
Don't I feel like an idiot? Yeah.
that's the other thing that confused me a lot. So.
Okay, all right. So there was a new question that came in, though, so let me get it right this time. Boy, I'm an idiot. So are there any options to reduce the overall deployment time, since bake process does tend to take a lot of time?
I'll take means, this is happening in AWS, right? The bake process. Spinnaker is really taking the information and passing it on to AWS, and that's the time it takes. But Spinnaker is intelligent about if it sees there are no changes. And Gopi, correct me, it doesn't rebake, and there is an option to force a rebake if it's needed. And I think in my scenario, I think I had that. And it's an option you can choose. So you need not rebake every time. If your things haven't changed, you don't need to rebake. But if your REST package or if your package has changed, you have to rebake or bake again. And at that time, the time AWS takes is the time AWS takes now. That's what it is. And again, it varies quite a lot. It probably depends on the type of machine you use, speed, and all that. I've had times take all the way from 5 minutes, 8 minutes to even 2 minutes today. It finished. So,
yeah, some of it also depends on your Packer template and how you're building it. So with this, it does add few minutes, but the immutable server pattern really helps when you actually go from your testing to deployment. Having that server that has been tested is what you're deploying. So yes, it adds few minutes, but you can optimize it through your Packer templates and how you structure your images. But it's definitely a useful pattern.
Excellent.
There's another question: is Netflix running Spinnaker in multi-region? And multi-region not recommended outside of Netflix? Yes, Netflix is running Spinnaker in multi-region, but they're also using a different database in the backend, and it's basically CockroachDB is what is being used, and that does the multi-region replication for them. And there are also some extensions that they have done on top. So essentially, right now, open source Spinnaker by default supports MySQL as a backend database. And converting that to Postgres and using these multi-region databases will allow you to run multi-region active kind of Spinnaker. Reach out to us if you want more information on that and how to do it.
Great. All right. Okay. Guys, I don't see any other questions, so I guess we can go ahead and look to wrap up. I think, again, I want to thank everybody for coming to the workshop. Hopefully, you were able to sort of get some ideas and maybe see some things that you hadn't seen before, depending on sort of your level of maturity with Spinnaker and sort of how familiar you are with the various concepts and deployment strategies. So hopefully this was helpful in sort of exposing you to some of those things. We continue to be willing to sort of answer any questions that you might have. So again, swing by our booth, let us know sort of how we can help. We obviously, as you can tell, love talking about this stuff. We certainly have a passion for it, and would love to chat with you a little bit about if you have a specific situation you want to just trade some ideas on, or sort of get our opinion. We'd be happy to sort of help you out there. Outside of that, I hope everyone really enjoys the rest of the conference. I know there's a lot of great sessions on the docket here over the course of the next couple of days, and look for us in the various chat rooms and at the various sessions. And again, more than happy to help any way we can. So really appreciate everyone's time today. And with that said, I think we're going to be in a position, unless Nirmalaya or Gopi, you have any last thoughts, we can give everyone a few minutes of their time back.
No, thank you for joining us today. We do have our booth. Reach out to us or reach out to us directly if you have anything that you'd like to discuss.
Great. Same here. Hope you enjoyed the session. And if you have any questions, obviously the booth's there. Come by, ask. And beyond Spinnaker Summit, if you have any questions, we are on the Spinnaker Slack channel too, or reach out to us directly.
Excellent. All right, guys. Well, thank you, everybody. Again, enjoy the rest of the conference, and have a great rest of your day. Thank you.
Enjoy, guys.